So what we're going to do is start talking about electropneumatics. So electropneumatics is essentially we're adding electrical control to our pneumatics. So essentially what we have to do is we have to add two things, inputs and outputs. So you know all about solenoid valves. You've learned a little bit about that from the labs, and we're going to be talking about that today a little bit more. But lab 5 really unpacks what a solenoid valve is and how they work. So kind of lean on that for the technical things, but I'm going to talk about more practical and what's actually happening with the solenoid. So we're also going to talk about those inputs. And the inputs, well, you know what inputs are, electrical systems. They're push buttons, and we also have pressure sensors, like pressure switches. Really, we'll talk about pressure switches. Pressure sensors, you'll be talking about sensors in mechatronics too when you get into that. And limit switches. So limit switches are really what we're going to be leaning on. We're going to be leaning on start, stop buttons. We're going to talk about what an emergency stop is as well, because it's important to put these emergency aspects into our circuits. So let's just kind of get rolling and take a look at some symbols, and we'll unpack how each one of those symbols works. So essentially what you need to know is the outputs. Really all your outputs are going to be, you might have a light or a buzzer come on or off, but we're focusing on pneumatics. So the control of the pneumatics, let's stick with our solenoids. So what's happening here is I'm going to actually draw the solenoid. On a solenoid in a pneumatic circuit looks like this. In an electropneumatic circuit, that's what a solenoid looks like. That's the symbol. There are no other fancy ways of drawing that. There's just one type of solenoid, and that's what it looks like. So the way that a solenoid works is, essentially what we're having is, I'm just actually going to draw a really simple DCV valve here, and I don't really care what the configuration is. And you know, it could be a 3-port, 2 position. It could be actually a 5-port, 3 position. It doesn't really matter. What we do is, we take this symbol here, we put a little block over there, and then we run a line down like that. And that's a solenoid A. This is solenoid A. So they are the same. Now we can do whatever we want with this valve. We can put a spring over here, or we can put another solenoid, or we can put a pilot there. You can even put a push button there if you wanted. You can pretty much get any valve built to whatever specifications you want if you're a really special application. But let's just kind of stick with electropneumatics right now. So that's the symbol for a solenoid valve, whatever that valve looks like. So for a solenoid symbol on a valve, whatever the valve looks like inside, it doesn't really matter. So let's move on from here. We're going to talk about limit switches. Limit switches come in kind of more varieties. As a solenoid valve, that one output is nice and simple. It's just one kind of output in pneumatics, and it looks like that. There's a solenoid symbol. What we do for our limit switches, all limit switches are going to start like this. They're going to have these 2 little dots here, and those are the contacts, right? And I'm going to draw a couple over here as well. We kind of have 2 kinds of limit switches. Okay, so I've got 1, 2, 3, 4. I'm going to draw the 4 types. Starting over here, I'm going to draw a normally open limit switch. That's a normally open limit switch. It's actually called held open. Now, let me just roll with me on this one. So I'm going to go down here, and I'm going to draw this line over to here, and I'm going to draw that. This is a normally open, held, closed. So what we do is we actually draw the limit switches in the state that they're normally in. And now I don't mean that, you know, I mean obviously when we have a push button, I'm going to draw the push button in its normal state. If it's a normally open push button, I draw it like that because normally it's open. In this case here, I'm going to draw normally closed. So I think I'm going to reiterate my wording here. We draw limit switches not only in their normal state, we actually sometimes don't draw them in the normal state. We draw them in their held state. So if a limit switch is in a situation, a normally open limit switch, where it's in a situation where nothing's pressing down on it, and nothing's normally pressing down on it either. Let's say it's an outside limit switch. So let me just draw a cylinder here, a really basic cylinder. I'm going to draw that guy. Now I'm actually going to put a limit switch over here. Now this is actually how we draw limit switches. Let's call that a normally open limit switch. Okay, so I'm going to put a spring on it here. So we're just going to draw a little contact in there. Now this guy over here is the same limit switch. I'm going to draw a line down there, and I'm going to draw this there. Okay, so now again, this is cylinder A. That's limit switch A minus, limit switch A plus. Now that's how we draw limit switches. We know that those are normally open limit switches because we've drawn the contacts open. Now, when we actually draw those contacts in our ladder, we have to think about if they're held or not. And what I mean by held is in their normal state, in that when the whole circuit is in its normal state. Let's say that, you know, I had a control system where if I pressed a button, the cylinder would go out and come back, and then it would just be like that all the time, unless I actually press that button. So normally, that cylinder is retracted. So that means that the normal state of the cylinder itself, or of the whole system that's running, is cylinder A is normally retracted, unless it's actually working. But if you shut it off, it's retracted. So that actually means that A, this guy here, let's say this is limit switch A minus. Limit switch A minus. So limit switch A minus, we would actually draw it in our circuit like this. We would draw it as held closed. Yeah. So let's go over here and draw a little bit more. Let's draw this guy, and this guy is going to be just the normal state. So this is normally closed, held closed. And I think the word held in its normal state, like if we actually just draw a pneumatic, if we draw a limit switch right there and nothing's actually holding it, so nothing's actually pressing on it regularly, we still call it held closed. But even though it's not actually being held, we like to put the H there. So in this case, what I'm going to draw this guy, and this guy is a normally closed, held open. Okay, so I kind of like this a little bit better because it's actually being held by something. So if we were to take a look at this and say, if I were to change this guy over to here, and if I were to change him as a normally closed, I would draw this like this. Let's just say they're both normally closed. So if they're both normally closed, and I would draw this one like this, and I would draw this one like this. Because the inside limit switch normally is activated. If it's a normally closed switch and I'm holding it in its active state, it's going to be open. I think that makes sense. So what we do is with limit switches, just to kind of reiterate that, with limit switches, we draw them here, either normally open or normally closed. And I'm going to unpack that a little bit. I'm going to draw one of those a little bit better in a second. So we draw like that as normally open or normally closed, and we just call them normally open or normally closed. But when we actually draw them in our ladder, it's more like we're drawing them how they're working. And it's not like this. I mean, it's kind of like this, but I kind of don't like to say this. Let me just draw this, and let me just put a motor in here. Okay, so let's just say I had a motor here, and I have this switch here. Now, that's a single pole, single throw switch. Every time I go over and I close the switch, I'm not going to run over to my drawing and draw it like this, right? So we don't regularly draw contacts in their held state. But in pneumatics, and more specifically when we're doing ladder logic, we do draw them in their held state. So when you're drawing your ladder logics for these, you have to think about if the cylinder is there or not regularly, and if that's going to be held. And this is actually going to help you a lot when you're designing your ladder logic. So I did say I would draw that again. Let me just erase this. So we're learning some new symbols. We know how to draw a limit valve. But in this case, we're going to stop saying valve, and we're going to start saying switch, because they're actually switches. We're not using valves anymore. Valves send an impulse of air to another valve that makes it go. But in this case, we're sending an electrical impulse through a switch. So limit switches look like this. Now, in this case, I'm going to put a spring there because it's going to have a normal state to it. We want limit valves to have a normal state. Sorry, we want limit switches to have a normal state. So in this case, let's say it's a normally open. I'm just going to draw this guy like this. So again, if I wanted to draw this as a normally closed, I think we get it. This guy's going to come down here. I'm going to put a spring on it because it has a normal state. And I'm going to do this. And I'm just going to do that. So that's one normally closed. And again, when we're labeling these, if this was for cylinder A, I would call that limit switch A plus or minus, depending if it's the outside or the inside limit switch. Again, when we're drawing these in our ladder logic, you have to think about how they're held. When the circuit is just not working, is one of them open or closed? Is one of them being held in a particular state? And that's important when we get into the logic of things. So that's this nice short video right here about these guys, limit switches, and the symbols for limit switches, and the symbol for a solenoid valve, the fact that one is an input and one's an output. Now I'm going to do some more videos on ladder logic.